During these notes, you're going to learn how to use the Pythagorean theorem to find the missing side of a right triangle, which would include both the legs and the hypotenuse, and then use the Pythagorean theorem to decide if three sides could form a right triangle. So the first thing that you need to know is what a right triangle is, which is a triangle with a right angle, and it has specific names. So the two sides that form the right angle here, those are called your legs. And we're going to call those sides A and B in the theorem. Could be A, could be B, they could also be switched, but they're called your legs. And then the side that's located opposite the right angle, it's across from the right angle, it's also the longest side, is called the hypotenuse. And in the formula, it's going to be C. So the formula is going to consist of A, B, and C. A and B are your legs, which form the right angle, and the hypotenuse is the side opposite the right angle. It's always C, and it's also the longest side. So the Pythagorean theorem says that if you square the two legs, so if you square A and B and add them, it equals the length of the hypotenuse squared, which is C. So pretty easy. A squared plus B squared equals C squared. We're always going to use this formula. It never changes. It always goes in that order. The plus sign is always between A and B, and it always equals C squared. So we're going to use it to find the missing side. So the first thing that we would do is write down our formula, A squared plus B squared equals C squared. And in this problem, you can actually see that they're giving us A is 4 inches, so I'm going to replace A with 4. So 4 squared plus 3 squared equals C squared. So I keep working in that vertical format. I keep my C squared. I also know I'm finding the hypotenuse because it's the side opposite the right angle that's missing. So now I'm just going to do the math. 4 squared is 16. 3 squared is 9. So 16 plus 9 will equal C squared. And then I can add those together. So 16 plus 9 is 25. So 25 equals C squared. But my objective isn't to figure out what C squared equals. I want to know what C all by itself equals. So to do that, the inverse of squaring is to square root. So I'm going to square root both sides, and I get a final answer of C equals 5. So pause the video. You're going to try this example on your own. Very similar to the one that we just did. Press play when you're ready to check your answer. So again, on this example, you're given the legs. You're given A and B because those are the two sides that form the right angle. You're missing the side that's across from the right angle. So A is going to get replaced with 5, so 5 squared. B is going to get replaced with 12, 12 squared. You could have also switched them. You could have made it 12 squared plus 5 squared, and that would have been fine. And then you square 5, which you get 25 plus 144, which is 169. But again, at this point, you're not trying to find C squared. You want to find C. And so to do that, you would square root both sides. C equals 13. So this example is a little bit different because if I start by writing the formula, A squared plus B squared equals C squared, this time I have one of my legs because I have one of the sides that forms the right angle, so I can replace A with 4. But then I have a 9, and since that's located opposite the right angle, that's actually going to be C. That means I'm missing B. So I can keep it a variable. I can keep it as B, or I could change it to X, so I'm just going to keep it as B. And then I can do the math, so I have 16 plus B squared equals 81. And then I have to get B by itself, so I have to inverse the squaring, and I also have to inverse the 16. So I'm going to go in reverse PEMDAS. So I'm going to minus 16 from both sides, and I'm left with B squared equals 65. But again, I don't want to finish with what B squared is. I want to know what B is, so I'm going to square root both sides. And you can type that into a calculator, and you would get B equals 8.06. That's your final answer. So again, you're going to pause the video, you're going to give this one a try, and then you can even move on and try these two word problems right here. Press play when you're ready to check your answers. So in this first example, you're given B and C, so you don't know A. When you plug them in, you get A squared plus 36 equals 49. You'd isolate A by first subtracting 36, and then to finalize it, you would take the square root. So A is about 3.61. On the next example, since you're trying to find the distance of a throw from person A to person C, you're actually finding the hypotenuse of a right triangle, and we know it's a right triangle because it's a rectangle, and rectangles have right angles. So we have our two legs, A and B, which add up to 724, but then we want to isolate C by square rooting, so approximately 26.91. The last problem on the soccer field, so here we have the end of the 18-yard or the 6-yard box, which would form a right angle with the goal line. So we do have a right angle in there. And so again, we're trying to find the hypotenuse. So 40 squared plus 12 squared equals c squared. 1600 plus 144 would add to 1744, so approximately 41.76 yards. Since the Pythagorean theorem will only work for right triangles, we can use the Pythagorean theorem to determine if three sides could form a right triangle or not. So I'll write down the formula, and then I'm going to plug in the numbers. So A would be one of the legs, 15 would be one of the legs, and 17 would be the hypotenuse. And I know that because if these three sides were to form a right triangle, which I don't know yet, but if they did, the longest side, which is 17, would be the hypotenuse. So that has to take the place of C. It's convenient that all the numbers are written in the correct order. Be careful when you try these on your own. The longest side always has to be C. So now I'm just going to square all these numbers. So I'm going to get 16 plus 225 equals 289. And then I keep my 289 over here because that's not going to change. And then if I add 64 and 225, it adds to 289. So because the Pythagorean theorem works, that means that if I were to make a triangle out of those three side lengths, then yes, they could form a right triangle. Notice how much work goes into showing that it's a yes. Putting just a yes or no wouldn't be sufficient. You need to support your answer by plugging into the theorem. Pause the video, try these two examples. Press play when you're ready to check. Keep in mind your answers should either be yes or no, but you need all of this work to support that. So in the next example, the first thing you have to be careful of is that 9 is the longest or the biggest number, so it would be the hypotenuse if it could form a right triangle. Then you do this out, so you get 25 plus 64 equals 81. 25 plus 64 adds to 89, which is not equal to 81, so no, they could not form a right triangle. Over here, 13 would be the hypotenuse if you have a right triangle, so you put that in the place of C, and after squaring and adding, you get 169 equals 169, so yes, these three sides could form a right triangle.